Hello, geometry students. Mr. Zacek back here with you in Unit 4, Lesson 5. We're going to talk today about proving angles congruent. And at the beginning here, we have a definition of a theorem. A theorem is a conjecture or statement that is proven true. So given information, definitions, properties, postulates, and previously proven theorems can be used as reasons in the proof. So the difference between a theorem and a postulate or a property is we have to prove that the theorem is true. And so throughout the course of the year, we're going to prove not all of the theorems, but we'll prove some of the theorems to show that. And so we're going to prove the vertical angles theorem. And the vertical angle theorem says that vertical angles are congruent. You know, if two lines intersect, then they form congruent vertical angles. We're going to prove that here. So angle 1 and angle 3 are vertical angles. That is our given information in this question. Now, angle 1 and angle 2 are supplementary angles. If we look up here, what do angles 1 and angle 2 form? Well, they form a linear pair on this line. So angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. They also form a linear pair. So the reason is angles that form a linear pair are supplementary. Angles that form a linear pair are supplementary. So now we can say the measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 2 plus the measure of angle 3 equals 180. The reason for that is that supplementary angles add up to 180. Okay, so supplementary angles add to equal 180 degrees. Supplementary angles add to equal 180 degrees. Now, since both of these add to equal 180, we can substitute 180, or substitute what I just circled in for what I underlined there, and that is the substitution property. All right, now, how are we going to get from there? The measure of angle 2 equals the measure of angle 2. Well, that's the reflexive property. Look in the mirror, anything itself. So how do we go now from, how do we get to step 6? Well, what would happen is, to get down here, if we subtract the measure of angle 2 from both of these sides, we would be left with what we have down here in step 6. So that's going to be the subtraction property of equality. Okay. And then in our last step, angle 1 is congruent to angle 3. And then, so we can just say this, angles with equal measure are congruent. All right. And that is the proof for the vertical angle theorem. So we used definitions to prove that since given angle 1 and angle 3 are vertical angles, that they are congruent. Now, how are we going to use this for us this year? The reason that we're going to use, what this kind of unlocks, this proof unlocks for us, is if two lines intersect, then they form congruent vertical angles. So that's how we're going to use this theorem, and we've already done that in our proof parts sheet. If two lines intersect, then they form congruent vertical angles. If two lines intersect, then they form congruent vertical angles. So that's what we are proving there in that theorem. So I'm going to give you a few other ones here, and we're going to use the vertical angle theorem here in this proof. Now there's a bunch of ways to display a proof, and a paragraph proof is written as sentences. So we could write a paragraph proof to prove this one. I just want to show you that we can kind of do this in more ways than one. All right, so here's how we could say this. We know that angle 1 is congruent to angle 4 because it is given. So what do we know? Angle 1 congruent to angle 4. All right, now think of, after your givens, this is kind of the order that we will work through with proofs. Given, and next we're going to look for our freebies. And our freebies are vertical angles. So what do we know now? Well, we know that angle 1 is going to be congruent to angle 3, and angle 2 is going to be congruent to angle 4, because intersecting lines form congruent vertical angles. So we know that angle 1 is congruent to angle 4 because it is given. Also, we know that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4 because if two lines intersect, then they form congruent vertical angles. If two lines intersect, then they form congruent vertical angles. Okay, that's our reason. We made a statement, we made a reason, okay, and we made a statement and then a reason, but we're just writing it as a paragraph. So now, what can we say? If we go back here, let me highlight this. So we've got angle 1 congruent to angle 3, angle 2 congruent to angle 4, angle 1 congruent to angle 4. So now we can replace those and say that 2 is going to be congruent to angle 3, or angle 3 is congruent to angle 2 using the substitution property. So you could say, therefore, we know that angle 2 is congruent to angle 3 because of the substitution property. All right. Now, a lot of times we're going to write these in a 2-column format, but I just wanted to show you that we could also just write it as a paragraph. And essentially, what the statements and reasons are is we make a statement because, and the because answers the why question, and then we give our reason. So again, we could do that in different formats here. All right, now the next thing I want to do is just give you some other angle theorems. And when you see these, what you should think of as these are reasons that can be used in proofs. So we're building our kind of proof toolkit. We've got our one sheet that we did here earlier in the unit. That's a primary one, but we're adding some other ones onto it. And so if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So think about supplements as adding to 180. So if angle 1 and angle 3 are supplements, and angle 2 and angle 3 are supplements, then angle 1 is congruent to angle 2. So just to help you with this, let's put some numbers in it. Let's say that that this angle is maybe, let's say angle 1 is 70 degrees, and angle 3 then would be 180 minus 70, okay, it would be 110. So they're supplements. They have to add to 110. And if angle 2 and angle 3 are supplements, that means angle 2 would also have to be 70. So therefore, angle 1, is congruent to angle 2. So if two angles are supplements of the same angle, then the two angles are congruent. That's a reason we can use. All right, here's another reason, building our toolkit. If two angles are complements of the same angle or of congruent angles, then the two angles are congruent. So remember, when we're thinking complements, that's complementary, means they add to 90. So here's a scenario. If angle 1 and angle 2 are complements, so let's say that, I don't know, angle 2 is 50 degrees. That would make angle 1 40 degrees. And angle 3 and angle 2, so angle 3 would also need to be 40 degrees. All right, then we can say that those angles are congruent to each other. All right, here's one that we've seen before. Again, this is a reason. All right angles are congruent. All right, so if they're right angles, we can make a statement that they're congruent. And then our last one, our last reason is if two angles are congruent and supplementary, then each angle is a right angle. So if two angles are congruent, that means they're the same, okay, and supplementary, that means they add up to 180. So they got to be equal, they got to add up to 180. What does that mean? Well, they both have to be 90-degree angles. They both have to be right angles. All right, so we've got a few more reasons that we're building on to our proof toolkit. In your assignment here, and as you're getting ready for the next quiz, make sure that you're paying attention to vertical angles and you're looking at that idea. When you have intersecting lines, you recognize that they form congruent vertical angles. That's a really big concept for us. So good luck here with your next couple assignments, and please ask questions to help clarify your understanding of things. All right, see you soon.